Okay, welcome back. Again, thank you very much for your hard work. I hope actually that you've had a chance to have a little look at these while you've been doing your worksheet, because actually what we'd do as teachers in the classroom, if you were struggling with something, we'd come and sit with you and we would go through a couple with you and we'd get the answers right and make sure that you understand what's going on, rather than leaving you to go piling through answering every question wrong, because that's not what we want. We want, as teachers, we want you to do the best that you can and to learn. And so if you do need to come and look at these anytime, the videos with the answers on, please do, because actually that's what we would do in class. We would go through it with you so that you knew some of the answers. So the first one, again, question number 1, I like these because actually it's nice and visual, and I like it when it's nice and visual like that. So you can see, right, so we've got 8 fifths, and we know there are 8 fifths because they're in fifths. So 1, 2, 3, 4, 5. We know that because that's the whole shape, okay? And actually what we can do is, so right, how many are shaded in? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 fifths, which is what's showing here. And of course, we don't do that because that's an improper fraction, so we need to convert it. And we can convert it by either doing division problems. So we can say how many 5s are in 8, which is 1, and there are 3 left over, so 1 and 3/5. Or we can look at this. We can look at this visual here and say, right, how many whole ones are shaded? 1. There's 1 there. 1 complete shape is shaded in. And then we can go down below and say, right, how much of this shape is shaded in? So we've got 1, 2, 3. 3 of 5 is shaded in, so 3/5. So we know it's 1 and 3/5. So we can go down to this one now. And again, we're working with fifths here, so 1, 2, 3, 4, 5. But this time there are a few more. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 fifths, and that's what it says here. There are 12 fifths shaded in. Okay, so we can look at that and we can say, right, okay, we could do our division again. We can say how many 5s are in 12. And we can say, right, there are 2 5s in 12, because that makes 10, and there are 2 left over to make 2 and 2/5. Or we can look at this because it's nice and visual and say, right, how many whole ones? 1, 2, and how many left over? 2 of 5, so that's 2/5. So there's 2 whole ones and 2/5, so 2 and 2/5. Here we come down to this next one. Different fraction this time. We're looking at quarters, and so we've got 1, 2, 3, 4. And we know they're quarters because it's cut into 4s, and we don't say fourths, although I did say it a few times yesterday. We say quarters. Alright, so we can count them all. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 quarters shaded in, okay, because these aren't. There are 9 quarters. So what we could do is we could say, right, how many 4s are there in 9? We could use our division skills again, and we know there are 2 4s in 9, because the 2 4s are 8, and that leaves 1 left over, so it's 2 and 1/8. Or we could look at this lovely visual here, and say, right, there are 2 whole ones shaded in, and there's 1 quarter left over. So there's 2 whole and 1 quarter. And then we can go down to the bottom here for the last one, and this time we're looking at thirds. As you can see, like 1, 2, 3, this is cut into thirds. And we can say, right, how many thirds are there? 1, 2, 3, 4, 5 thirds are shaded in. It's important we only count the shaded in parts. Okay, and we could say again, how many, we could do our division, we could say how many 3s are in 5. We know there's 1, 3 and 5, and there's 2 left over, 2/3. Or we can look at this great visual again and say, right, there's 1 whole one there, and then there are 1, 2, 2/3 shaded in there, 2 parts of 3. So it's 1 and 2/3. Alright, this one at the top here, we now have to shade in, okay, to represent each improper fraction. And this is really important. Some of you didn't quite get this yesterday. So if it says 7/3, you have to colour in 7 of the blocks, 7 parts of this fraction, okay? So you colour in 7, and if you do that, it then looks like these over here and makes it much easier. I mean, if you wanted to, you could then go, right, okay, we've got 7/3, we know it says 7/3 here. We could use our division. We can say, how many 3s in 7? There are 2. There's 1 left over, so it's 2 and 1/3. But it's asking you to shade the model in, okay, to show that you really understand. So you need to shade in 7 parts. So you can see 1, 2, 3, 4, 5, 6, 7 have been shaded in here, 7 thirds. And so we then say, right, we can see there's 2 complete shapes shaded, 2 complete thirds shaded, and there's 1 third left. So it's 2 whole and 1 third left. Okay, 2 whole and 1 third. And down here, we're working with thirds still. This time it says, can you shade in 8 thirds? So you need to shade in 8 sections. 1, 2, 3, 4, 5, 6, 7, 8. Remember, you only shade in the amount that it says. If you shade in more, if you shade in less, you're not going to get the right answer. Okay, so we can then look at this and say, right, how many whole shapes are shaded in? We've got 1 here, we've got 1 here, so we've got 1, 2. So we know it's 2 whole ones, and then this down here is our fraction left over, so it's 2 of 3. So 2 parts of 3 are shaded in, so it's 2 thirds. So it's 2 and 2 thirds. Right, we're working with quarters down here, and it says, can you shade in 9 quarters? So you shade in 9 quarters again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Shade them in. Make sure you shade them in properly, and make sure you shade in the right number, because it will really help you to visualize the answer. And so we've got 9 quarters. And again, if you wanted to just do how many 4s in 9, that's 2 with 1 left over, you could, but actually it's nice to show that you fully understand by shading these bits in. So now we shade in the 9 quarters, we can say, right, how many whole ones? 1, 2, so it's 2 holes, and then there's 1 quarter there shaded in, 1 of 4 shaded, so that's 2 and 1 quarter. And then lastly, we're looking at fractions again. We're looking at quarters down here, and this time it says you need to colour in 11 quarters. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 quarters shaded in, and it's really important that you shade in the right number. No more, no less. Remember, this number here, the numerator, is how many you just need to shade in. Alright? When it shows you that number, that is the number you need to shade in. Right? And then you can say, okay, how many complete shapes are shaded in? And again, we've got 2, which is just the same as this one here. But the answer is a little bit different because this bottom row here is different. So how many are shaded in of the bottom row? 1, 2, 3, or 4. So it's 2 and 3 quarters shaded in. Right, let's move on to the other side. Right, so this time it says, okay, convert the improper fraction into a mixed number. So we've got the improper fraction here, and we need to convert it into a mixed number. And this time we don't have any shapes or anything else to show us. But you could do, if you wanted to, you could draw on this one here, you could draw 10 circles, and then you could box them off into 2s, and then you'd know that that was 5. You'd have 5. Or you could just use your division skills. So how many 2s are in 10? 2, 4, 6, 8, 10, 5. Okay, 5. So the answer to that is 5. B, again, if you wanted to, you could draw 10 circles, box off the lots of 3, okay, and that would give you the answer. Or you could just use division skills. So how many 3s are in 10? 3, 6, 9. We know there are 3, okay? Remember, if we're counting in 3, 3. It's 9 is not the answer, and I know some people were doing that yesterday too. 9 is not the answer. It's how many 3s, okay? Not what 3 gets to. So 3, 6, 9. So it's 3, but then there's 1 left over because it's from 9 to 10, it's 1. So 3 and 1 third. Again, number C, we've got 10 at the top. Again, you could do your 10 circles if you wanted to, box them off into 4s, or you could use a division skill. So how many 4s are in 10? There are 2 4s in 10, so 2 4s are 8, yeah? So we know that there's 2. And then there's, of course, we got to 8, so that means there are interesting. It means there are 2 quarters left over. So we could say 2 quarters, but what this person has done here is they have changed it from 2 quarters, 2 and 2 quarters, which you could do. which would be the right answer, but also 2/4 is the same as a half. So they've converted it into a half. So 2 2/4 or 2 1/2, both are the correct answer. Okay. Right, 10/5 here. This is quite a nice easy one because we could say, right, how many 5s are in 10? We know there are 2 5s in 10, nothing left over. We don't have any remainders, we don't have any fractions left over, so there are 2 5s in 10. That's it. And again, if you wanted to, you could draw out 10 circles and you could box up the 5s and you'd see that there was 5, 2 lots of 5 circled and nothing left over. Right, a few different numbers up here, a few different numerators. So we've got 12/5. So again, how many 5s are in 12? And again, if you wanted to, draw out your 12 circles, box off your 5s, no problem at all. Keep doing that, every one if you wanted to. So how many 5s are in 12? There are 2 5s. 2 5s are 10. Okay, so we know that that's 2 whole numbers. But that leaves, from 10 to 12, it leaves 2. So we know that the 2 remainders become 2/5. So it's 2 2/5. Then we go to this one here. We got 13/6. Again, we go, how many 6s in 13? We know there's 2. 6, 12. Yeah, that's 2. 12 isn't the answer. 2 is the answer. 2 whole ones. Okay, and then we have from 12 to 13 there's 1. So that's the remainder 1 becomes 1/6. So again, like I say, if you wanted to draw out 13 circles and then box off the 6s, so it's nice and visual for you, please do that. All right. Now we've got 13/7. This one's a funny one. So we say, how many 7s are in 13? There's only 1, because if we go 2, it goes to 14, and that's more than our numerator, and we can't do that. So how many 7s in 13? It's 1. So that's the whole number there. But how many are left over? That's quite big, so we go counting on. So 7, 8, 9, 10, 11, 12, 13. That's 6. So 6 remainders, that 6 remainder becomes the fraction. So it's 1 6/7. And then we've got this big old one down here. So how many 8s are in 31? And it's not far off 4. It's not far off 4 there really, but it's confusing us because it's just not far enough. If it had been 32 8s, 4 would have been just the right answer, but it's not. So we go, how many 4s, how many 8s are in 31? So we go 8, 16, 24. Unfortunately, that is it. That's as high as we can get. That's as close as we can get. So it's 3. It's 3. So we can get 3 8s into 31, but then we've got 7 remainder. Okay, it's remainder 7. So from 24 to 31 is 7. 24, 25, 26, 27, 28, 29, 30, 31. Okay, so that means that remainder 7 becomes the fraction 7 8. So 3 7/8. Okay, right. Now we've got Eva down here. She's got 7 bottles of juice. Each bottle contains half a litre of juice. How many litres of juice does Eva have altogether? Write your answer as a mixed number. So what you could do on this one is you could just count in half. So half 1. Remember the number line we saw at the very beginning of the lesson, the main input. So we go half, 1, 1 1/2, 2, 2 1/2, 3, 3 1/2. So we can count in halves. I like that. Half, 1, 1 1/2, 2, 2 1/2, 3, 3 1/2. And that's, so she has got 3 1/2 litres. A bit wasteful, really. Are they half litre? Are they full half litre bottles, or yeah, they're not litre bottles. They're just half in. I thought she was being wasteful for a minute. Okay, so that's that one there. Right, so we've got Dexter up here. Dexter is converting improper fractions. So what he's doing is he's saying, right, okay, 32/3 is the same as 3 2/3. This is what Dexter is saying. Is Dexter incorrect? Well, it says he's incorrect, but why is he? So what we need to do is we need to try and work out how many 3s are in 32. And we know straight away that actually he's saying there's only 3. But that's far from wrong. Right, so we work it out. How many 3s are in 32? So we go 3, 6, 9, 12. And again 15, 18, 21, 24, 27, 30. So that's 10. Okay, so it's 10. There are 10 3s in 32. We know that, so this answer here should be 10. And then he's got this bit right, actually. It should be 10 and 2/3 because there are 2 left over. Because 10 threes are 30. We got that remainder 2, and then we convert that into the fraction. So it should be 10 and 2/3. So Dexter's incorrect because he's just worked it out. He hasn't got the right whole number. So I don't know where he's got 3 from. Poor old Dexter. Right, can you find the value of the circle? And the value of the circle is 5. These are tricky. I find these very tricky. They're not easy to do. So basically, when we look at it, we need to go, right, okay, we've got 27 as a numerator, but over here, we've got 2. Okay, so whatever this is here, this number, it needs to divide into 27, but have 2 as a remainder. Okay, so then you think about it, okay, right, so actually, there can only be one number. It can only be 5, can't it? So how many 5s are in 27? 5, 10, 15, 20, 25. So you put 5 in there, 5 whole ones, and then there's 2 left over because from 25 to 27 it's 2. So 5 and 2/5. Okay, so the number for each of those is 5. And then lastly, we get this again, really tricky one here, and it wouldn't surprise me if you'd have to come to the video to try and look at these ones, because they are difficult. Okay, so it says find 2 possible values this time for the star and the triangle. Okay, so again, what you need to look at is this. Because this number here is here, it means whatever number divides into 30, you need to have a remainder of 2. Okay, so we can see, look here, we've got this star. This star here is 14. So how many 14s in 30? That's 2. Okay, because it's 28. But that means, so that would be 2, but it means we've got 2 left over. Okay, so 2 14ths. So 30 14ths equals 2 and 2 14ths. And then it gives us the other answer here, which is actually, you think about it, when we look at fractions that are equal, we then think, okay, so we've had 14. What we could do is we could half that. We could half this number, okay, we could half this number here, which is the denominator, and we can double the numerator, or double the whole, which would give us the answer, which is very complicated now. So basically, we had 14 here, so we half that to 7. So right, then we say, how many 7s are in 30? So we go 7, 14, 21, 28, and the answer is 4. There are 7. There are 4 7s in 30. So that goes in there as the whole number, 4. But then again, because it's 28, the same as 14, we know there's 2 7s left over. 7ths, sorry, should I say. Okay, so 37ths equals 4 and 2 7ths. Yeah, nice. I quite like that. Quite tricky. Actually, it gets the whole brain working, doesn't it? I'm not sure that at this time of night my brain needs much working, to be honest, but still, I like it. I hope that that's sort of explained it for you. Again, like I say, even if you want to come and look at these answers and then go back to your work afterwards and say, look, you can redo it if you want to, or you can scrub them out if you're using the online worksheets or whatever. You can do that, but like I say, please come and have a look at the answer one as often as you want, because it's there to help you, because we want you to get it right and we want you to be able to understand, and it's not always the easiest. I hope I didn't go through that too quickly. Thank you again. I'll see you a little bit later for literacy. Thank you.